Students, welcome to my YouTube channel. In this video lecture, we are going to answer the new questions from the first chapter of Keith Williams' Weight and Balance book. Let's begin with question number 41. What is the all-up mass of aircraft with basic empty mass, DOM, zero fuel mass, traffic load, and fuel so and so? Now, all-up mass means nothing but takeoff mass, right? So, uh, the takeoff mass of this aircraft will be dry operating mass plus useful load plus useful load. So over here, takeoff mass equals to DOM plus useful load is your takeoff mass. A useful load is made up of takeoff fuel and traffic load. So let's substitute the values. Dry operating mass, useful load. In place of useful load, I'm going to write traffic load and fuel fuel. So 32,500 plus 8,300 plus 12,200. So 32,500 plus 8,300 plus 12,200 is equal to 53,000 kg. So the answer is all of mass of this aircraft 53,000 kg. Okay. DOM plus traffic load plus fuel. Next. What is the DOM with basic empty mass 1875, takeoff mass 3620, takeoff fuel 380, traffic load 1150, okay, and landing mass 3280. So again, we will use the same formula, takeoff mass equals to dry operating mass plus useful load plus useful load. So dry operating mass plus useful load is nothing but fuel and traffic load, right? So dry operating mass. So takeoff mass is 3,620. Dry operating mass as it is fuel 380 and traffic load 1,150. So dry operating mass equals to 3620 minus 380 plus 1150. 3620 minus 380 plus 1150, that is minus 1530. So 2090 kg. So dry operating mass is 2090 kg. Which of the following statements is true of regulated takeoff mass? Regulated takeoff mass is okay. So like I said, regulated takeoff mass can be performance limited takeoff mass or maximum structural takeoff mass. Now let's say performance limited takeoff mass is 20,000 kg and maximum structural takeoff mass is 15,000 kg. So in that case, regulated takeoff mass will be 15,000 kg. You're going to select a value which is the smaller one, a smaller value between performance takeoff mass and structural takeoff mass. Okay. Now, structural takeoff mass, I have repeated this in many lectures. I'll say it again, is a value, is a fixed value given by the manufacturer. Performance takeoff mass, or performance limited takeoff mass is the takeoff mass calculated by the pilot, taking into account or considering outside atmospheric conditions like density, altitude, the runway distance available for takeoff and landing, the obstacles in the climb path of aircraft at departure airport and destination airport. So all these factors will influence the weight with which you can take off. Okay, with the weight with which you can load your aircraft, because this weight will influence the landing distance, the takeoff distance needed, the speeds, as well as your rate of climb, etc. Right? So performance limited takeoff mass is that thing. Okay, it's a variable quantity changing from flight to flight depending on payload, outside temperature conditions, etc. Whereas maximum structural takeoff mass is a fixed limitation assigned or given by the manufacturer, keeping in mind the load bearing capacity of the structure of that aircraft. So regulated takeoff mass will be always a lesser value. We are going to select a lesser value which is going to fulfill both the conditions of performance limited takeoff mass and maximum structural takeoff mass. Let's say performance limited takeoff mass is now 20,000 and maximum structural takeoff mass is 25,000. So in this scenario, regulated takeoff mass will be equal to performance limited takeoff mass because now performance limited takeoff mass is less than maximum structural takeoff mass. So, so now regulated takeoff mass is another term for the structural takeoff mass. Wrong. It's the greater of the performance takeoff mass and structural takeoff mass. No, it's the smaller one. So wrong. It's the lesser of performance limited takeoff mass and the maximum structural takeoff mass. Yes. It's another name for performance limited takeoff mass. No. So Charlie. Next. The dome of aircraft is takeoff mass minus. So just now we did one numerical based on this formula. Dome equals to takeoff mass minus useful load. Minus useful load. So the useful load is made of two parts, that is usable fuel, right, and traffic load. So option Charlie is the right answer. Basic empty mass of aircraft is the basic aircraft plus variable loads, basic aircraft plus traffic loads, empty aircraft, basic aircraft plus removable equipment. So basic empty mass is the standard mass of your aircraft, is the mass of your aircraft plus standard equipments inside like unusable fuel, oils, oxygen equipments, emergency equipments, any supplementary electronic equipments, all that. So now alpha will be wrong because it does not include variable loads. Variable loads is included in dry operating mass. Again, traffic load is included in zero fuel mass, right? Removable equipment. So removable equipments are again included in variable loads or dry operating mass. So Charlie is the right answer. Basic empty mass is nothing but your empty aircraft, and this empty aircraft will still have unusable fuel, oil, fluids, etc. Okay. Next. Maximum ramp mass. Now ramp is the position or place at airport where aircraft is parked for cargo loading, for boarding of passengers, for fueling, etc. Right? So its maximum ramp mass is a fixed value stated in the manual, a value which varies with conditions, outside conditions, a value which varies with flight distance, a value which varies with pressure altitude. So correct answer is a fixed value stated in the flight manual by the manufacturer. So maximum ramp mass. So that means the maximum mass to which your aircraft can be loaded when it is parked at the ramp. Okay, so the maximum ramp mass means the maximum, or it denotes or it signifies the maximum capacity to which your aircraft can be subjected to in terms of maximum fuel, payload, cargo, etc. Okay, so that is your maximum ramp mass and it's a fixed value. It's a structural value, so it's going to be fixed. We have only performance limited values in terms of takeoff and landing. We do not have performance limited ramp mass. We do not have performance limited taxi mass, nothing like that. Okay, so ramp mass and taxi mass only exist in the form of maximum structural mass. Okay, whereas takeoff mass values and landing mass values are available in both structural limitation wise and performance limitation wise. So remember that. Next, the dome and zero fuel mass are the same thing, are always equal, differ by traffic load, differ by unusable fuel. So remember, dry operating mass and zero fuel mass differ by traffic load. Traffic load is the link between dry operating mass and zero fuel mass. Next, which of the following is most accurate? Zero fuel mass equals to dry operating mass minus basic empty mass? No. Dry operating mass is zero fuel mass minus traffic load? Yes. Traffic load is DOM plus zero fuel mass? No. Zero fuel mass minus DOM is equal to traffic load? Yes. So statements Bravo and Delta are the right ones, right? So zero fuel mass minus traffic load is DOM. Zero fuel mass minus DOM is your traffic load. Okay, so two possibilities. So statements Bravo and Delta are the right ones. So you're going to select that option which has both the statements in it. So we'll stop here. I will do the next questions from this chapter in my next video lecture. So I hope to see you all there. I request you all to subscribe to this channel if you haven't yet. Share this lecture with your friends who are also preparing for exams, and hit the like button if you have liked this video lecture. See you.